Welcome to the problem section on finding an equation from its graph. We're going to do a small number of problems. We have given again the graph, and we're supposed to figure out what the equation is for that graph. And then this time around, I believe we're going to graph them every time on the graphing calculator, and I'll do that every second problem. That way I don't have to switch forth and back that often. Okay, so the first one, it starts as a cosine here, as we can see. So it starts on the crest. It goes a full period from 0 to 2 pi to the next crest. So we have a period of 2 pi. Its amplitude, and actually that should read absolute value of amplitude, looks like it's 3. It has no vertical shift, and it has no phase shift. As you can see, it's neither shifted left or right, so no phase shift. And then the coefficient b comes out to b equals 2 pi over a period, so 2 pi over 2 pi is 1. That makes sense. We're just going to have cosine x. We have an amplitude of 3 in the front. We have coefficient c of 0 because the phase shift is also 0. So our equation is 3 cosine x. The next one, we start this curve here at 0, and then one full period goes to 2.094. And I also have to say, well, one full period here, this looks like a sine. So one full period, 2.094, I have to compare that to what that possibly could be in terms of sine, in terms of pi, and one possibility seems like I'm going to use 2 pi over 3. In fact, that's what it is. 2.094. So the period comes out to 2 pi over 3. The amplitude goes up 1 box here, so that's 1. There seems to be no vertical shift. There seems to be no phase shift, as it turns out it's x equals 0. And then we determine the coefficient c is 0, of course, and the phase shift is 0. And the coefficient b is determined as 2 pi divided by 2 pi over 3, so we come up with the 2 pi cancels, and we're left with 3. So we have sine of 3x. Hardly gets any easier than that. Okay, let's go to the graphing calculator and graph these two. There it is. Okay, that's from a previous recording. Okay, the first one we had is 3 cosine, and we're going to graph that between 0 and 2 pi. Yep, pi over 6, that's fine, and we had an amplitude of 3 anyway, so I might as well do the y values between -3 and 3. And there it is, exactly 1. Exactly 1 period. And the other one is simply sine 3 of x, sine 3x. And let's see, the window for exactly 1 period, we start at 0, and then we go to 2 pi over 3. We have an amplitude of 1. I can just leave my y values here, -3 and 3, that's fine. And there's the sine that we came up with. As you can see, it goes, since I use increments of 30 degrees, it goes to 120 degrees, which is 2 pi over 3. Okay, I'm going to go back to the problem section, and let's see if I was able to take along one of the graphs. Yep, there it is. So the first one looks just the same, and the second one I will paste in at a later time. Okay. The next one, oh, I wanted to take something along, which are these two equations. All right, almost there. Okay, this one here starts at 0 and then goes down a wonderful period. Since it starts at its 0 line, it should be a sine. It's actually upside down, so it's reflected, so it's a negative. I will insert the absolute value signs here for the a later on. Well, maybe I'll do that right now. I must have forgotten them when I prepared this problem section. All right. Almost there. Okay. So back to this one here. So we have an upside down sign. It starts at 0, which means it has no phase shift. It goes all the way up to 2.0. Again, you might be able to read that in the script. So we have a period of 2. We have no vertical shift, so that's 0. Our amplitude looks like it's 4. And therefore, the coefficient b comes out to 2 pi divided by 2. So b equals pi. And c comes out to 0. As we can see, there's no phase shift. So we have negative 4 sine of pi x. Okay. And the other one that we have here, I'm going to take this down so I have it better available. Apparently I wrote a lot of text here for the next one. Okay. So on the next one, it starts at its crest, so I should have a cosine. It's right side up, so it's going to be plus there. Has an amplitude of 3. It has no vertical shift. It does have a phase shift. Let's see by how much. Again, only I can perhaps read these here. Negative 0.7854 is the phase shift. Well, that's pi over 4. So phase shift of pi over 4. The total period goes from 0.78 to 2.35. When you add the two, you come up with around 3.14, which means pi. Pi. So the period is pi for this one. Let's see what else. Oh, okay. Now we can determine the coefficients b, which is b equals 2 pi over the period. 2 pi over pi is 2. And this time around we have a coefficient c, which will be negative b times phase shift, so negative 2 times pi over 4, so we're going to have negative pi over 2. So negative pi over 2. Okay, so the equation is going to look as follows. 3 cosine of 2x minus pi over 2. Okay, here's something that I had mentioned in the lecture, that a graph could lead to two different functions, sine or cosine, of which both are correct. For example, the above could also be, if we started right here, it could be a negative 3 sine of 2x. Why did we choose this cosine here? Well, because, over this sine equation here, well, because the graph that is shown is exactly one period of the look-for function, and that takes away the ambiguity. So it's exactly one period here, and that means this must be a cosine. That's what's asked for. That's the preferred one. But as I said, the other one is still correct as well. Okay, let's graph these two, and I'm just going to double check because in my notes, did I make a mistake here? Somehow in my notes I have it a little bit different. Oh, yeah. Here's my mistake. I found it. The phase shift is to the left. That means negative 0.78 is negative pi over 4. So there's a negative right there. The C comes out then to negative 2 times negative pi over 4. So it comes out to positive pi over 2. There's my mistake. Plus right there. And that plus pi over 2 you will ensure that the graph is being shifted to the left. Okay, let's go over to the graphing calculator. Again, I will graph the last two problems that we have. Whoops. I meant to go to the graphing calculator. Wherever it is. All right. Let's see. Y equals. I'll do this again just to be on the safe side. Clicked a little wrong a couple of times. All right. So the first one of the last two that we just did was negative 4 sine pi x. And we should graph that between 0 and 2. So 0, 2. And here I should use a scale of 0.5. And we have an amplitude of 4. There we go. And that looks same as what we have given in the problem. And the other one that we just had, 3 cosine of 2x plus pi over 2. Okay. The window that we should choose would be between negative pi over 2 and 3 pi over 2. No, that's not right. Let's see. Oops, I made a mistake here too. This was supposed to be pi over 2. Must have accidentally multiplied negative. I start over again. It's supposed to be negative pi over 4, our phase shift. And then this one here is supposed to be 3/4 pi. There we go. 3/4 pi. And then I might want to, again, have a scale of pi over 6. And I'm going to amplitude of 3. So what I have here is all right. Okay, and there it goes. And it looks exactly what we had given in the problem. Oh, and then actually what I meant to do is write down the equation here. Okay, screenshot. And go back and insert that. So that was this one. Okay. Couple more. Again, I like to have these equations available. To page through my notes here. Okay, this one. The shape of it, well, starts as a cosine, so it should be a cosine. There's a vertical shift. We can see that, negative 3. So we have negative 3 here. We have an amplitude of 3 as well, and it's a right side up cosine, so it's plus 3 cosine. So equals 3. The period, it starts at negative 0.78, ends at 2.35, so we have a period of 2. And again, just a quick thing here, I should have absolute value signs around amplitude. There we go, that looks a little better. So period of pi, and this time around we also have a phase shift, and shift it to the left by pi over 4. So I have negative, this time I take care of the negative, pi over 4. That means we have a coefficient b of 2 pi divided by pi, so 2. And we have a coefficient c of negative 2 times negative pi over 4, so positive pi over 2. Okay, so we have negative 3 plus 3 cosine 2x plus pi over 2. Okay, and one more. Okay, on this one, looks like we have a sine curve, because it starts with its 0. We have a vertical shift of negative 2. Amplitude of 2. It's a right side up sine, so we're going to have negative 2 plus 2 sine. With a period, it starts at 0.52, which is pi over 6. So I'm going to note that on the side, and it ends at 2.61. So 2.61, and as I said again, I'm able to see that 2.618 minus the 0.5236, 2.094, that looks like 2/3 pi. I'm going to check that. 2/3 times pi. Okay, yep, 2.094. So the, where was I? Period. Oh, 2/3 pi. Yeah, 2/3 pi. That means that the coefficient b is 2 pi divided by 2 pi thirds, so b comes out to 3. The phase shift is going to be, let's see, it's shifted over here to 0.52, so pi over 6 to the right. So it's going to be positive. Whoops, didn't mean to have that. Positive pi over 6. And the coefficient c is negative 3 times pi over 6. So it's going to be negative pi over 2. Negative pi over 2. So we have negative 2 plus 2 sine 3x minus pi over 2. Okay, and we graph these two, and then I believe I'm done with the problem section. Of course, when I graph on the graphing calculator, these are all checks. Okay, the first one was negative 3 plus 3 cosine 2x plus pi over 2. And I would like to graph that from negative pi over 4, there it is, to, what was again 3/4 pi, scale of, oh, I can leave it at pi over 6, but then it goes all the way down to -6, so I'm going to do actually -7, and the largest y value I'll put at 1, and then it looks just like what we had given in the problem. And again, I can put the equation in there. Okay. And the last one says -2 plus 2 sine 3x minus pi over 2. And the window setting, I would like to have the x-axis in there, so I start at 0 instead of pi over 6. And then I go to, how much was it again? 2.618. Is it again? It's not 3/4, is it? Pi over 6 plus the period, and the period was 2/3 pi. So I'm going to come up with, let's see, 4.56 pi maybe. Try that 5 over 6 times pi. Yeah, that's it. So I'm going to go to 5 over 6 times pi. Okay, this will be fine here. Now I'm going to go down to from -5, and I'm going to go to, oh, perhaps 2. Okay, I'm going to graph. I'm going to point out where the graph starts, actually. Right there. This graph starts as a sine, and there is one period. As I said at the very beginning, there's a little bit graphed too much there. All right, let's trace this one here. So I have the equation, take a screenshot, copy that, and insert it. And this is the last graph here. And as we can see, it looks just the same as the one that's given. Just in the beginning, I graphed a little bit more. The graphing calculator, of course, cannot get rid of it. With that, I'm done with the problem section for finding an equation from its graph.